I'm doing a monthly newsletter called 3 Minutes with Joe, and trying to keep it just to 3 minutes and really, good bits of information within that 3 minutes.
Yeah. I think we should just talk about some of those things and current events and get caught up with Podge.
Sure. Well, you and I, we have children in that age, and my youngest is hoping to go to Clemson. So the advice I give young men and women thinking about being an engineer is to get the best value, but also the best education. Where those two intersect, and usually that's a state school. With that said, so where we live, that would be Clemson, South Carolina. Um, he's already been accepted into USC, University of South Carolina, and that's a fine school. And his other option is Georgia Tech. Um, but you know, you don't want to go into a lot of debt getting an education, right?
No. Well, congratulations, first of all.
Thank you.
Yeah, that's exciting. When does he start? Next year? Where are we at? November?
Yeah, it'll be in the fall of next year, and I've started taking on interns who want to be electrical engineers. Because Jarrett, my son, he's in a program to fast track kids to. Uh, it's a basically dual enrollment, um, but the idea is that most schools he elects to go to, he'll have at least 30 hours under his belt when he gets there. So a lot of the kids that are within his class, I interview, and once a semester, I pick one to be an intern. Um, and they help me do anything from checking arc flash studies, not like the content of the study, but for typos, um, checking against the single lines and stuff like that. Um, it's been fun. I've realized just how much a 4 year degree and field experience will take a person, over his next 4 to 5 years. Um, the one I have now, he wants to go to Yale, but I'm trying to discourage him from that. But he's got his heart set on Yale.
That's aiming big. That's all right.
Oh, he'll get in. He'll do well. He's a sharp kid. He'll watch this,
Well,
I'm sure.
congratulations. All right. Some exciting news from the Chacon family.
Yeah. Well, that's the intern. My
Oh,
son.
I see.
Yeah. So I'll pick up another intern in the spring, and hopefully through this program at USC Upstate, I'll continue to have one intern a semester and maybe even do it for the summer.
No kidding. Okay, so what does the intern get to do at Podge?
um, well, that's very dictated upon the customers, but for this particular one, his name is Cameron. Um, he's done some calculus for me. I've done some DC fuse pre-arc clearing times and post-arc clearing times, and they have a particular time constant called tau, it's L over R, inductance over resistance, and that determines how fast you reach steady state on a fault. So that was the best system where he helped me out with that. Basically reviewing my math. Um, I tell them do not use OpenAI, Copilot, anything. So I say I want to see what you know. So I think he's faithful to do that. He'll check some arc flash studies for me, not the equations per se, but the output. Make sure I got everything typed in right. I didn't fat finger anything, stuff like that. I got all the buses. We're doing some very massive arc flash studies these days, 3,000 buses. So that's a lot of items to check and make sure all those labels are good.
Wow. Okay, so this is quite a challenge for an intern, and they're in college. How old is Cameron? I
He's
mean, tell me
18.
that. Oh my goodness. Okay, you're starting young.
Yeah.
You're starting them young.
Yes. Yes, I've learned a lot with them too. So the calculus and some of well, I mean, he's taking calculus 3,
Okay.
so he's quite capable of doing this. But
Yeah.
it's all theoretical, right? You know, I had to explain to him what a fuse was, for instance, right? And its purpose. Um, you learn all this stuff in school, but until you actually see it and put your fingers on it, uh, and it's an electrical, even smell it sometimes, you
Yeah.
really, you're really at a disadvantage, right?
What made you want to start taking on interns?
I have a passion for the next generation. Um, we've talked about this before with the Wand of the Wind Turbine book. Um, and I'm very optimistic about where the next generation is going. Um, I mean, you and I probably have 10, 20 years and we'll be in retirement, right? And I definitely believe in engineering. I believe in the future. And that was really why I did it.
Wow. Kudos. That's wonderful. Yeah, okay. I don't know. Sometimes I think retirement is a thing, it doesn't exist. I sometimes wonder, what can I do forever? Right? How can I contribute in some way? I think is the question I ask.
I agree with that. I'd like to be doing something, until the day I die.
Yeah. And it usually ends up with teaching, right? That's the kind
Yeah,
of
it
energy
does.
we have left later in life.
It does. I mean, do you really see us at 90 years old at the top of a turban teaching somebody? I don't know.
No.
I'd like to think so, right?
I don't even see myself in very many meetings. But right.
Mm,
But there's always a way.
yeah,
All right. Well, very exciting. Um, and that's one intern a semester. Okay. It's a big commitment.
it is.
About how many hours is Cameron having to
10
run
hours a
math for
week.
you? Really?
Yeah.
That's a big commitment.
Yeah. He's a math tutor at the university. So, along with Jarrett, my son. So, their ability to commit to much more than that is difficult. And of
That's
course,
plenty.
Jarrett, my son, he has to work for me whether he wants to or not. I mean, he gets paid, of course, but um, he's done a fair amount with me as well.
Very cool. I have a similar story. Colton, my son, has to work for me, whether he likes it or not. Gets paid, yes. Yeah, I understand this. Very cool. And what else is going on? So, what inspired the 3 Minutes with Joe newsletter?
Hmm. Adam, you always ask insightful questions, and I never know how to prepare for our interviews, but that's what I like about it. It's impromptu, and you make me think on the spot. Um, so, business development. um, about a year ago, I had a business development guy, and um, it was working out okay. the The problem is is you want to grow like a use an L over R time constant, right? You want to grow at a certain L over R time constant, not too fast, not too slow, but just right. So the BD guy, the business development guy, was bringing in just tons of opportunities and trying to parse through them all, get proposals out. Um, it was a bit of a challenge. So 3 minutes with Joe is a way to talk about things that we're doing at Podge LLC, or Chacon Engineering. That's a sister company, just basically for the state of California or New
Mm,
York. But it's just an idea to get some thoughts out in front of people, hear back from people. I get a lot of response. A lot of people reply, um, and say, "I never really thought about this. This is insightful. Thanks for keeping us in the loop." And it was really a way to control the growth a little bit more organically, instead of just going after things you see here, things you see there. It was my way of controlling our growth a little bit.
interesting. I was not going to guess anywhere aligned with business development. But I get it. Sharing information and then trying to, intrigue or get people interested in an offering or a service, a capability. I was using it for educational purposes. The first couple, I thought it was there. And I forwarded them to the Altair personnel with a little note, and I thought just education. That's how I was looking into it.
Well, I mean, it's meant to be useful and educational. The one I did last time on RCAs, um, I mean, there's many different ways to do an RCA. And the company you and I used to work for, a very high executive reached out to me and just loved it, gave lots of feedback. And we started talking about the methods we used at that company and how he had others that he preferred. And, the one that I wrote about, the 5 why, that's the most simple one, but I had never used that until like the last 3 years. You ask why 5 times, just five. And if you can't get to it in that amount of questions, then it's probably best to use another model like Fishbone or 8D or something like that.
There are a lot of different, I don't know, what you call them, processes to perform and execute an
Yes,
RCA.
there are. And even within a broader system, they could be a particular piece of a broader system, like Six Sigma, for instance. Define, measure, analyze, improve, control. That improved piece in and of itself could just be the RCA process.
Right. Why are there so many different processes? That always confused me.
Oh, I don't know. I like that there are many options. It's kind of like CAD softwares. Why are there so many? Why are there so many cell phone technologies? And why there's so many arc flash softwares? um, the one I like the most are the ones that I'm comfortable with, but I'm open to trying other ones. Um, if it's something that's very deep and complex, and I have a customer that needs something with a little bit more rigor, there's other outside consultants I'll go to. I mean, you've had some on your podcast that's that's their core competency. It's not my core competency, the process. I much rather prefer to be, a subject matter um, personnel on that, not the process oriented person.
Yeah, thanks. That one always confused me. There were so many different books on it, so to speak,
Yes.
and how to do it.
Yeah, and really the industrial engineers are more suited, system engineers and industrial engineers are more suited for that. It's not that other engineers can't lead a good RCA, but some of them get really complicated.
Yes. Yes. Um, always there was always something for me to learn along every RCA process with our former employer. That was it was difficult for me. I don't think I see the world quite the way I needed to to be good at it.
Yes, yes, and my other son and I were talking about this the other day about paralysis of analysis, and how sometimes he just gets stuck and doesn't want to move forward. And the more RCAs you do, the more intimidated you are about just going and trying something. Um, so our former employer, they adopted a process about failing fast, and persevere and pivot and things like that. So there's even a process for managing what you know and what you don't know, and how comfortable you are with what you don't know.
Failing fast is something that I'm good at. That one I like. I don't know if it's always the right process, but very efficient.
But you're
That's
pretty
good.
good at deciding, do I keep going this path, or do I change, or do I tweak? And that's really important. Many people just stuck and won't move at any direction.
Oh, I gotcha. Yes. Anytime I find myself going down the wrong road, I'm okay to turn around and go back and find a new route.
Yeah.
Sure, I gotcha. We'd like to thank our sponsor, Altair Energy Services, and their highly trained, expert technical staff, leveraging decades of renewable power management experience into customized solutions for everyone to meet their energy goals and contribute to a better future for all. Altair's team of hardworking, respected experts are providing full scope, turnkey repairs, planned and unplanned maintenance, system upgrades, fully autonomous technical crews, supplemental staffing, and customized dynamic scheduling to fit your power production needs. Contact Altair at info@altairenergyservices.com and learn more about their wide range of capabilities across multiple power technologies and platforms. So what's going on with so many arc flash studies coming your way?
Um, well, they're due every 5 years. Um, so there's that requirement. Plus, in 2018, IEEE 1584 changed.
Yeah.
Um, so the methods to do the calculations have changed, and it's for the better. Um, you have, I've talked with many people who struggle with interpreting, uh, reading the label. And you know, you've had a lot of good people that come on that teach training that, you know, limited approach boundaries, restricted approach boundaries. What's a calorie per centimeter squared? You know, what's a working distance? You know, what's your voltage and things like that. Um, it's really difficult to produce a proper study in 2025. So I make it my practice whenever a client reaches out to us to do an arc flash study for me to actually go to site. I want to look at multiple things. One thing I want to look at is the condition of the equipment. I need to take measurements on the pieces of equipment. That's something that changed in the 2018 edition. You need to know height, um, height, width, and depth of the particular equipment. You also need to know the distance of what they call the electrode separation. That's how far your bus bars or conductors are separated. And then you also need to know the orientation of said bus bars, whether they're vertical or horizontal. So you can have, like you take for instance, something that has horizontal bus bars and you bend it towards the operator, that's going to be significantly different incident energy than if you had just kept the bus bars like this. So
Hmm.
that's why I like to go out and take a look at it. I'll open it up and I will look at all those different types of things uh, and bring back that data and plug it into the software to do the incident energy calculations. And if you remember last time, I harped on um, one label per enclosure unless it is arc resistant. And how do you know if it's arc resistant? You see an ANSI C37.20.7 sticker on it. And renewables, we tend not to have those.
Yeah.
Um, the only place I've ever seen them in renewables is in General Electric wind turbines. I've never seen one in solar, and I've never seen some other places. I saw some switchgear in a turbine recently that attempted to make it arc resistant, but they didn't have the label on it. So, as such, you can't deem it as arc resistant. So, why is that important? Like, take a solar inverter, for instance. Um, you have your AC coming in, and that usually comes to a main breaker. And then you'll have some bus bar that'll usually go across the top of said solar inverter. Okay. So then that comes down usually vertically to IGBTs or some type of pulse width modulation switching technology. So that horizontal bus bar, once it gets into an arc flash, it's going to propagate across the entire lineup. So the only way to know that if that incident energy is less in adjacent compartments is with the ANSI C37.20.7. Now, there are some tricks that engineers can do if the client insists, I want to have like an aux cabinet label or this type of label. The best thing to do is for the OEM to separate them in completely different enclosures. That's not economically viable, though, is it?
Ah, okay.
Yeah. So you take, for instance, remember that General Electric turbine I was mentioning to you? Um, that has one lineup, but if you look, that one lineup has different compartments and everything is sectionalized off, and you have plenums to redirect the incident energy. And that was tested in a laboratory. The only way to get that certification is to have that test certificate so that you could put that label on. So that's why I don't put more than one label on a piece of equipment unless I see that. And then if they insist, the client insists, I can do it, but um, it's I got to have a very good reason to want to do it before I put my stamp behind it. So
Interesting. What what makes a piece of equipment? Did you say arc resistant?
yes.
What makes something arc resistant?
So with arc resistance, um, it's impossible to contain the arc flash. Uh, it's just not going to happen. Um, well, it's not going to happen for certain KVAs and certain voltages. So let's just say once you get up to 480 volts and over 1,000 KVA, you're starting encroaching 30, 35, 40 calories per centimeter squared. That's a lot of energy.
Hmm.
Um, as you increase the KVA, you don't have to increase the voltage. In fact, increasing the voltage sometimes reduces the incident energy, oddly enough. Um, but as you increase the KVA, you'll see many solar inverters now that are 4.4 megawatts or higher. So you'll see some of them come in at 250 calories per centimeter squared. Some of the best systems can easily get above 1,000 calories per centimeter squared just because you have multiple packs of batteries and astronomical amounts of fault current, sometimes 150,000 amps of fault current at over 1,000 volts DC because there's just so many batteries. Um, and you have L over R time constants that accelerate that fault current 300, 400, 500 microseconds. Uh, it's just a lot. Um, so, did I answer your question?
I have a few more now. And the container box, whatever it's in, can it contain the arc flash when it occurs?
um,
What happens if the arc
so,
occurs?
so to comply with that standard, the ANSI standard that I mentioned, the enclosure has to remain intact. Now the doors can bow, that's fine, but you don't want projectiles coming off. Um, they also take these pieces of cotton that are about the size of my hand. They're 100 millimeters by 100 meters squared, and they put them on a grid. I think I said that right. Yeah, it's about that big, 400 millimeters by 400 millimeters. And then I think you set them also 100 millimeters apart. Um, I'd have to go back and read the standard, but the
That's
idea
all
is
right.
that you have this basically sheet of cotton that is 4 inches or so away from the equipment. And when that arc flash happens, so normally what we'll do is we'll take a 10 gauge wire that's bare and wrap it around all the bus bars, and then you'll energize that equipment and poof, it explodes. Okay. So none of the pieces of cotton can catch fire. The doors have to remain intact. The hinges have to remain intact. That's for a front facing piece of equipment. So the idea is you want to redirect the energy and you redirect it away from an operator. So most motor control centers, they'll put these flaps on, perforated flaps, and they'll give way and they'll
Mm,
open and the energy comes out like that. Uh, it's very similar to what you see in hazardous areas where you have hazardous gases. They call those class one areas. So you have class one, division one, class one, division two. And on those, you have something called a maximum experimental safe gap, MESG. and it varies for each of the groups. You have Group A, Group B, Group C, and Group D. Um, and those are very armor tight, and those can sustain it, but they have this gap on the end because truly nothing's going to like stay rigid and survive it head on. It just has to be elastic, if you will. So and many of the incident energies that you see in an arc flash are just as much as a Tomahawk cruise missile. The temperatures do get as hot as the surface of the sun. There's no exaggeration there. So it's like the mantra: if you can't beat it, join it. So you do join it, and you redirect it and get it out of there, away from an operator.
Okay, thank you. So it's so the standard is to protect the doors because that's where your human is going to be, redirect, give it a new path because you're not going to be able to contain all of it.
Yes. Well, we call them plenums or chimneys or things like that,
Mm-hmm.
just to get the energy up and out, because it's a pressure wave.
Mm-hmm.
Okay. So that pressure wave has to go somewhere. Um, you don't want it coming towards you or me. So you redirect it to a safe place. So that ANSI standard, you define what the safe surfaces are. It could be front, it could be back, it could be front and back, it could be sides, and it could be intercompartmental. And it has a number and a letter to tell you, what it is. 1A, 1B, 2A, 2B, things like that.
I love that you compared it to the Tomahawk cruise missile. You did this last time, and if I remember, it was like you said 350 calories or something.
Oh,
No one no one has a suit. Is it bigger than that?
well, I have some customers who don't like to go above 40, and I have some
Yeah.
that don't like to go above 100. Um, OSHA, NFPA, and others are kind of on the fence about it. Um, it's debated, it's still debated. Um, it's not so much that one can't thermally, protect himself. Um, it's the percussive energy that could be quite damaging. Um, I mean, if you're exposed to a massive amount of percussive energy, it could do some internal damage to some of the organs.
No, I'm with you. I was liking that you were comparing it to some. I mean, okay, I don't know what it would be like to be hit by a cruise missile, but I know that I don't want to be anywhere near it, right? And so what I loved was you were relating it to things that, I could understand and other folks that don't understand, energy the way that you do. I just wondered if there were others, what would it be like to be near um, an arc flash in the 40 cal range, right? To reinforce, the safety message. I was just curious because I love that you were relating it to something so dangerous.
Yeah, yeah. I've been around a lot in the lab environment, um, in many different labs around the world, and even behind bulletproof glass, it's quite intimidating. Um,
Yeah.
I've fortunately only ever been around minor ones in person. Um, never around a major one. I've done a lot of RCAs for major ones. Um, they're very difficult. Many times a customer, uh, the way I look at an arc flash is, you do everything you can to reduce the likelihood it happened. Any risk assessment, you have severity and likelihood, that's your risk, right? How do you categorize them? If you have a likelihood of 10, but a severity of 10, you really want to do something about that. um, there are a lot of pieces of equipment that are more prone to arc flash than others. Um, and there's ways to remedy that. Yeah, I mean, we've talked about the OSHA hierarchy of controls before, I think. An administrative controls is the lowest form, of the hierarchy controls. Eliminate is, at the top. Right in the middle is engineered controls. So one of the things I like to do is when I do an arc flash is tell the customer, okay, if you do this, this, and this administratively, these are things you could do to reduce your exposure, reduce your incident energy, things like that. Okay, so I give them those options. And then I say, if you do, let's call that ABC for administrative controls. It's like, if you do XYZ for engineering controls, you could reduce the severity of the arc flash and things like that. So I have one customer right now, SEL Relays, Schweitzer Engineering Laboratory. They offer maintenance mode, not just Schweitzer, but other devices too. Or you can put it in another group. Pull down the clearing time, not clearing time, the instantaneous. They give them different numbers and ANSI language, 50 and 51. So one's instantaneous and one's long term. But you can pull that down, and you still have 3 cycles of clearing time to get to. One cycle is 16 and 2/3 milliseconds, right?
Yeah.
So
Yeah.
that's an eternity. So what I like to recommend to customers is go, how about we look at some current limiting fuses? Current limiting fuse, you're going to have an asymmetric offset that gets really, really high, and you can sometimes clear that in 4 to 5 milliseconds.
Okay.
Yeah, 16 and 2/3 milliseconds is almost an eternity for an arc flash. That's just one cycle of 60 hertz. You know, one advantage of 60 hertz over 50 hertz.
Right.
Anyway, don't worry about that. You can take
I
that part
gotcha.
out.
Little
But
less time.
um, yeah, there are a lot of things that can be done besides paying a lot of money to get an arc resistant enclosure, maintenance settings, current limiting fuses. I've seen people deploy fiber optic sensing technologies, but the big idea is to really get your clearing times down, limit your exposure. Administrative controls, we work at 18 inches. Um, you know, you can give somebody some human growth hormone to get his arms longer, right?
Of course.
I tease, but somebody introduced me to one the other day. I try to get out to the field as an engineer as much as I can. I've seen these leads that you could put in your fluke meter just to extend it another 18
Sure.
inches. So now you're at 36. You know that the incident energy decays exponentially the further you get away from it.
Yep.
So if you see the label and you see it says 60 calories at 18 inches, then go back and ask the engineer or supervisor, hey, if we had these leads, what is it at 36 inches? I think I'd like to know that answer. Wouldn't you?
Yeah. That's great. So, I mean, I think you kind of went through like a few different things that you can do, whether you own the power plant or working on the power plant to improve safety. So there's technology and components to clear faults. Did I say that correctly?
Yes.
And then there's also tools to keep you at a safer distance.
Yes.
And you don't always have to go and rebuild the enclosures or
Right.
make major changes.
Right.
You
Right. One tool that we sell, our company, Podge, is the OEM that makes it. It's called Grace, and it's a presence of voltage device. Um, and it's meant to connect directly to the bus bar that you would normally put your leads on to test that. So you put it in the enclosure. It's NEMA 3R. That means you could put it outdoors. Um,
mm,
it has LEDs on it. And when the voltage goes away, usually when it gets less to about 35 volts, the lights go off. And then you can come in with your leads, put them in, and do your, energized, de-energized, energized, or hot, cold, hot check right there as well. Um, and we don't put it behind a fuse. We put it directly to the bus bar. It has a high impedance on it. And that high impedance is something that Grace has patented in such a way that you can connect directly to the bus bar and not get a false reading that,
okay.
oh, my fuse blew, so I'm not really sure if I'm reading this right or not. Now, it does get a little tricky because The meter that you use is not going to tell you exactly what the voltage is. It's not meant to do that. It's not a precision device. It's a go no go device. And that's the beauty behind it. So if you're trying to read less than 50 volts, it can sometimes be, 30, 40 volts you need to look at instead of 50 volts. But the lights, they're going off. Now, you're still going to go in and check what you're working on, but you significantly de-risk that just by doing it there. So let's say you have a bus bar, my, where my microphone is, for instance, and the enclosure is already 18 to 24 inches away from that bus bar, and now you're coming in to read something that's already that far apart, and you're 18 inches away. So now you've expanded that gap by quite a lot, and you're probably only like 5 to 10 calories at that point. So
Yeah.
a very, very economical tool that could be deployed retroactively to any asset that has a large incident energy. Um, that
I
we've deployed.
remember you brought me one of those
I did,
the last
yes,
time you were here. By the way,
yes,
I love the name Grace. I don't know how that worked out, but that's a great name for it. How many of those are getting deployed? Are people starting to use them?
yes, yes. People are starting to use them. We did one prototype recently. We're writing a white paper. Uh, you know, I'm the engineering company and writing it with the company that did the installation. Um, you know, it's not something that's very difficult to do, very difficult to install. But you're going to want to pick more of your seasoned technicians to put it in because you are going to the main bus, and you want to make sure you get that done correctly.
Mm-hmm. And so, are you finding that the equipment that you're running the arc flash studies on needs some type of improvement, some type of an upgrade? What are you
So
finding?
in the renewable space, the answer is going to almost be yes. Um, the reason for that, so I do a lot of work in the industrial space too. If I'm doing something in the industrial space, I'm going to try to if somebody wants a service, for instance, I'm going to try to cap it at 750 to 1,000 kVA. Okay, whether that's 480, 600, it really doesn't matter. That's going to almost guarantee that I keep that incident energy low. Um, and I'm also going to put these customers. They have a lot more access to capital, and they don't have to hit a PPA target. For instance,
Mm,
um, they're hitting another target that's so putting in three $1,000 fuses for them makes sense all day, every day. It doesn't break the bank. So in renewables, particularly solar, on central inverters, I do see a lot of people after the asset's been there for a while, do something about that. But what I have seen is a lot of people take very seriously the administrative controls, the training, the NFPA 70E training, and things like that. So people are aware of the dangers, whether the customers can afford to deploy the engineered solutions. They're certainly doing very well with the administrative controls, and I applaud just about everybody I've ever worked with on doing that.
okay. Yeah, where to match up the answer with the money, right? is It's a
Yeah,
tough one, and understandably so, but a tough one.
yeah. It's the same with the power quality stuff that I do. A lot of times I like to liken it to our health. We could be told that we have a hearing loss, but it's going to be $5,000 to get hearing aids. How
Mm,
many people are going to really put the money into doing that? So everything has a particular cost that's associated with it, and I I try not to judge whether somebody does something or not. I mean, there's always a good reason for why a client wants to go one way and not another.
right, right.
I just
I
want to give
like
them options. That's all.
right. and see them go one way or another. Because that means an improvement, right?
Yes, yes. Most of
Yes,
the, I mean, they all want to do something to be better. I've never met one
sure,
that didn't. Um,
sure.
but they do have financial obligations and challenges, and the administrative control route. Almost always they do something there, and my hat's off to everybody that does that for real.
Yeah, very cool. I like how you always bring it back to health, and I think you brought one back to hearing aids the last time we were together.
Yes.
And then the noise cancellation feature, I don't remember the component name.
The yeah, that's how active harmonic filters work. That was
That's it.
the analogy I used. Yeah.
Right, right. I love that. And I don't mind sharing. I know it's a little personal for me, but we've talked. I just got the best report card of the decade on my personal health.
Hey, congratulations.
Yeah. I've worked very hard for that for a very long time.
Yes.
What's Up Renewables is growing, and we're looking for new sponsors to join us. Our show connects leaders, innovators, and field professionals across the renewable industry, and our sponsors are part of that conversation. Some have seen their network expand instantly. Others have grown revenue and brand visibility through the connections they've made right here. If you want your company to reach the people driving the future of clean energy, now's the time to get involved. Contact us at media@whatsuprenewables.com to become a sponsor today. I want to share a couple of things. I actually got to be a part of one of those arc flash studies, and I was trying to remember, I think it was 2009, not studies, tests. So I believe 2009-ish. I worked on designing a cabinet that added a synchronization switch to a 1.5 unit for Europe, Spain and Italy. And I'm not the design engineer, but I went to a lot of effort, and guys like you joined in and picked it up, and we put it together, and I got to go do the arc flash test somewhere in Iowa was the facility.
You
Eh,
you're not going to believe this, but you and I were together on that.
I wondered, I couldn't
Yes.
remember.
I was the design engineer for that particular
Okay.
product, and we were in Cedar Rapids, Iowa at the Square D facility, Schneider Electric facility for that.
Wow, your memory's better than mine. Yours is better than mine. We were there together?
We were.
Very cool. Well, I got to see how they light that box up. That was
It's
wild.
Yes, I'm glad you got to see it.
It
Um,
was wild.
yeah, every mean, you ever taken somebody into a hub for the first time and see the person's reaction? Arc flash tests are the same way. Um, it, it it puts everything in perspective, and nobody
Yeah.
really can appreciate it until you see one. And I've had to see many people who have seen one n- the wrong way, um, and those are always sad.
Yeah. Always sad. I've seen one. Oh, I've seen a few the wrong way. I've seen one face to face the wrong way. And I'll talk about it. I don't think I ever have on this, but and that company doesn't exist anymore anyway. But it was commissioning a wind turbine, and this was in northern Asia, and I don't know why, but a simple continuity check didn't find the problem. So when we engaged, there was 575 at the time, particular set of motors through a breaker and contactors, it shorted instantly. And what hurt the most was, or what was most unbelievable was how much smoke we were just, you just couldn't see instantly. And it happened so fast, you didn't have time to stop breathing and choose
Yeah,
to hold your breath. And it caused, vomiting and crawling out of there. It was horrible, horrible.
this was in a top box, I take it.
Down tower controller.
Oh, a down tower controller.
And trying to remember. I think it was a 550 kilowatt turbine. It ran on, it did kind of a soft start with silicone controlled rectifiers instead of a full synchronization um, design. So older unit, but unbelievable. I was there with two other people. One of them um, did suffer some burns to the eyes that
Okay.
they recovered from, but all three of us instantly couldn't breathe. The doors were wide open. Unbelievable, Joe. I've spent so many years scared to tell some of those stories, but I'm too old to be scared of that stuff anymore. And I think we should just share the stories, shouldn't we?
We should. Um, so what would you have done different now that got 30 years under your belt?
Well, I was not using any of the proper PPE.
Okay.
None of us were. So that would have been one. Um, Definitely would have looked for other tests in order to identify it ahead of time. I don't recall all the specifics now, but there should be a test that I could have ran to identify it. Other
Okay.
than, well, I don't know why continuity didn't, but um,
I like what you said there because there are many instances where energized troubleshooting is necessary.
yeah, yes. I've had a couple of folks on a safety professional that talks about facing the switch when you're switching, and and keep your eyes open. I don't think I ever did that again in my life. It was way too hard to recondition me. What else could we have done differently? I guess PPE for sure. And then bring in smart folks like yourselves and say we need to identify a new way to, um, give us a go no go before we switch that particular breaker.
Hmm.
Right? Clearly, I didn't know it at the time.
Um, so you see what we did there? We went back arc flash back to RCA,
That's right.
all in the same
Full
podcast.
circle. Full circle. Right. Get someone with the RCA.
I should ask you five whys now, right?
Mm-hmm. Well, this was boy, that was a full quarter of a century ago. So I don't know if I'd have very many answers for your whys today.
Well, you're still here to tell the story. That's the important part.
Still here, but what bothers me is we're still having arc flashes. We're still having um, electrical events that are harming people.
Hmm.
So sure, the equipment changes and more devices, components, and safety measures come in, but we're still having this occur in at least in our industry, right? Renewables, and I know you're in others, but electrically, and we got to stop. I don't know. So I think I just the podcast platform is a vulnerable one, so sometimes I'm cautious about what stories to tell.
Yes.
But the more that I hear about these incidents, the more courage I have to talk about some of my own and hope that others do too. And that we're just mature enough to talk about it so that we can get better.
Yes. One way I think to think about it is it's like autonomous driving vehicles. When the designers design those, they know that they're still going to get into accidents, right? Um, so engineers, whether you're doing an arc flash study or no matter what you're doing, you you try to you know that there's always the possibility to have an arc flash, and most of them are going to come from a human interaction, with a meter or something. Some commissioning, many of them occur during commissioning. You have this bath curve model, right? you know
Sure.
so I mean, yes, it is nice to try and eliminate them, but that's probably not realistic. So the next best thing to do is to minimize them. And I've seen many customers, and I can't give their names, of course, but they have remediation strategies. How can we reduce the incident energy. And that was I'm glad we talked about that today because there are a lot of things that can be done that don't cost a lot of money. They're just procedures. And there are things that could be done that cost just a little bit of money. Um,
Hmm.
but there's really no need to spend a lot of money. A little bit goes a long way. Um, your best health checkup was probably just from doing a lot of little things differently. Our flash is kind of the same way. Um, most of the time, there's no big obvious thing people have to change. Just one or two little things, and the probabilities of a catastrophe go down significantly.
Yes. Oh, you brought it back to health again. That's good. Uh, we're getting good at making these full circles. But you're right. My health and anyone's safety does depend on a whole lot of small decisions
Yes.
all the time. It just doesn't end all the time. And now we have you to take a look at the equipment that's operating and aged and what can we do to improve. And some of that is some of it just that it's an older piece of equipment and we have some new technology and these components are maybe cost a little less today than they did 10 years ago. Are there, is that a variable
Um,
or did some components just get missed when it was built?
Renewables is different. Um,
Ah,
it's
ah,
very different because uh, of that power purchase agreement. That you start there, and that drives everything from a cost perspective differently. So most of the time, if with safety and other things, people are going to try to take a software control, an administrative control, something that could preclude a massive capital expenditure. Um, and I get that. I get that, and that's where I like if I can understand a customer's pain points and understand where they are in the finance perspective, then I can help them tailor that solution to where it's the best of both worlds. Um, in the general industry, 1 out of 3 devices that's sold today is arc resistant. People just buy them right up front.
nice. Is
Yes.
that old technology? Is it relative? Is it newer?
No, these are going to be newer components. So all the big OEMs make that stuff now. Um, Siemens, Schneider Electric, ABB, they all make arc resistant gear. Um, they also have a lot more space, to do those things. Renewables is usually very space constrained, and
Ah,
and you're keeping it, to like I said, I try to keep it to 1,000 kVA or less. If you want to go more than that, let's do two, three, four, whatever. Um, but in renewables, you know, you're trying to maximize power density. How many kilowatt hours can you squeeze out of so many square meters, and how much
mm-hmm,
does that cost, right? So
mm-hmm.
those are your variables.
Well, it's nice to hear that the technology is improving so that you can get arc resistant components technology. I mean, that's a nice improvement, right? So there's more options for folks.
Yes, yes. And the more vertically integrated people get, and wind's very vertically integrated. And I didn't mean that as a pun. I mean that in terms of an OEM will make just about everything that's in that asset. Solar is not that way. Um,
Right.
so each one of those companies has to make money. So that erodes the ability to do something that I would call world class. But it doesn't necessarily need to be world class.
No, but very important to do that as built arc flash study then.
Yes, yes. And then you document your hazards, and then you know where they are. Um, I try to put a label on just about everything that somebody will service. So something even as small as like a met mast tower, for instance. It's got a little 120 breaker in there. I know somebody will flip it. I'll put a sticker on that too.
You always talk about those stickers and labels. I have a family member that is a safety professional for, call it a residential, commercial, industrial solar company. And they were just going through a company wide exercise of collecting photos of all of the stickers
Oh wow.
on all of this equipment because of, a lot of the same reasons that you're talking about. Some don't have any labels. And when I got that phone call, I said, "Find out how many have 2 labels. You've told me about this." And they went back and found some. They did, they found some. But this is, C&I residential as well, not utility space. But, yeah, solar. Um, I'm curious, are you hopping in the autonomous cars?
I see them a lot in your state. I don't. Uh, I would hop in one. Yes.
Yeah, I haven't done it yet. I'm
Yeah.
not sure I'll get there, but sometime.
Yeah. No. I when I worked at the space center, I would have hopped in the shuttle. That was a 1 in 100 chance, according to the risk assessment, that before it was ever built, that was um, a catastrophic event would happen. And as the program panned out, that's almost exactly what it ended up being.
Well, that estimate was right. Every time I see one, I remember you were saying how we need to be feeding that AI, and now we're feeding our vehicles. And it's fun.
Oh, they're feeding that AI for sure.
Oh my goodness, that is yeah, huge growth. And that will be partnered with a lot of battery storage and then solar as well, won't it?
I think so. I see a lot of gas turbine applications as well. Um,
Mm.
one customer of mine also works in gas, and he was boasting that they from cradle from the beginning to the end of the project, they did 90 megawatts in 90 days. It's like, wow, that's very impressive.
That's very impressive.
Yeah,
Like smaller generators then? How did they go so fast?
I think they were aero derivatives.
Okay.
So the jet engines that are applied.
Okay. That's fast.
Yeah, there's a lot of demand for gas turbines right now.
Right.
Mhm.
Very cool. Well, uh Joe, what else can you share with us? Current news, current events, things we should be paying attention to.
Um, well, I enjoy watching the podcast, and
Thank you.
I one of the things that I liked about it is being able to network with a lot of the people that you've had on. Um, you've brought a community together. That's we live all over this country, and even some places out of this country. Um, but I've probably met 4 or 5 different people who've been on your podcast that we've been able to collaborate and do some projects together. Um, you know, I
That
think
might
that's a really good thing.
that might be like the biggest compliment you can give Jacob and I. I mean, being able to create a community and have, folks be able to network together and grow, whether it's business or careers. That, whoo, that's a good compliment. Thank you. I'm
Well,
glad
my
that's working
pleasure.
out.
Thank you.
Very cool. Well, I don't know if I interrupted you. If
No, no, you did not interrupt me. It it has been neat just to hear people's different perspectives, different ways of doing things, um, and most of the people that you've had, not most, I think all the people you've had on have been very open, to phone calls. I haven't spoken with every person, but um, it's you've had a good group of people you've interviewed.
Oh, well, thank you. Appreciate that. And glad it's helping out you as well. Yeah, very nice.
It is, and it doesn't always mean a exchange of money. Sometimes it's just, hey, I got this. Hey, have you considered this? Sometimes just
Right.
simple phone call.
Simple phone call. Yeah. Or to get a question answered, even small things.
Yes.
Yeah. Very cool. Well, Joe, always enjoy catching up with you. And now I enjoy reading the 3 Minutes with Joe monthly newsletter. So appreciate you sending that out. For me, it's education. I
Thank
will
you.
always say that. And yeah, congrats on Jarrett getting accepted to, I already forgot the school,
Clemson.
Clemson. Yeah, very exciting news. All right. Well, look forward to catching up again soon and hope you enjoy the rest of December.
Thank you, sir. You have a good one as well. Merry Christmas.
And Merry Christmas. All right. Bye.
Bye.